So we learned about two quantum numbers, n, principal quantum number, and L, orbital angular momentum quantum number. And the third quantum number is magnetic quantum number, m sub L, magnetic quantum number. So every principal quantum number or every shell, main shell around the nucleus is divided into L, several L's in fact. So n equals 1 has L equals 0, which means it has one subshell. The name of that subshell is 1s because it belongs to the first shell and the value of L is 0. N equals to 2 has two subshells, L equals to 0 and 1, and their names are 2s and 2p because n is 2 and L is 1. Okay. The third quantum number, that means each L, each subshell is further divided into sets of orbitals. Okay. Orbital is a three-dimensional space. Three-dimensional space around the nucleus in which you will find the maximum possibility of locating the electron. There is a very high possibility of locating a certain electron. Now, what are the rules for the rules for m sub L? The rules for m sub L is that m sub L can take values from negative L all the way to positive L, including 0. So, what do I mean by that? Say, let's consider, for example, N3. N3. First of all, what are the L values? L values are L is equal to 0, 1 and 2. Right? Now, each of these will have its own m sub L values. This is the 3s, this is the 3p and this is the 3d, right? And each of them will have their own m sub L values. So m sub L for this would be, remember, negative L to positive L. So L value is negative 2, L value is 2 here. So 2, -2, -1, 0, +1, +2. 3p. So value of L is 1. So what are the values of m sub L? -1, 0 and +1. Value of L is 0. So m sub L is 0. So if you consider another example, say n is equal to 2 for example, right? First of all, again, what are the values of L for this shell? 0 and 1. So this is 2s and 2p. Okay. So L value is 1. So what are the values of m sub L? -1, 0 and +1. L is 0. So m sub L is 0. So what is the pattern that you have noticed? For a p subshell, whether it is 2p or 3p or 4p, whichever it is, there is 3 m sub L values. Right? So p subshell every time occurs as a set of 3 orbitals. S subshell occurs as 1 orbital. And D subshell will occur as 5 orbitals. And that is what I am trying to show here. S is a spherical single orbital. p set of 3 orbitals. Shape of this orbital is like this. Okay, so technically if you were to imagine it around the nucleus, there's the nucleus here and it will be around the nucleus something like this. Okay, because here it's the nucleus and there cannot be electron here, so technically like this. So this is along the x-axis, this is along the y-axis, and this is along the z-axis. 3 orbitals. Each orbital can take a maximum of 2 electron each. Okay, 2 electron. So since there is a set of 3 orbitals, 6 total. So any p orbital, 3p, 2p, 4p, 5p, 6p, any p orbital can take 6 total electrons. With d orbitals, these are the shape of the orbitals. This is double dumbbell in shape. Double dumbbell. Okay. 5 orbitals. So total of 10 electrons each. To summarize, this is a huge video. To summarize, m sub l, okay, magnetic quantum number. Okay, rules are negative L to positive L including 0. Okay, this is associated with shape of orbital in which electron is located. S orbital, spherical. P orbital, dumbbell. D orbital, double dumbbell. S can take 2 electrons, P can take 6 electrons, and D can take 10 electrons each.